Hello, this is Math with Beth, and I'm going to help you hopefully get ready to take pre-calculus. If you have taken it before and didn't do well, or you are about to take it for the first time, there are a handful of concepts you really need to make sure you are okay on, and this is just a few. So what I would do is I would pause it right now and I would try these problems and then see how I do them. If that's not enough, then I have other videos about these topics and I'll explain that at the end. Okay, so give them a try and then see what I do. So for factoring, you always want everything on one side with the 0 over here. So number 1 is ready to go. Since there's no number in front, this is the easier type of factoring for a trinomial where you always have x and x here. And now you need to find numbers that multiply to 24. So stuff like 12 and 2, or negative 12 and negative 2, or 6 and 4, negative 6 and negative 4, the list goes on. But which of these could get us to negative 10? So I can stop right now because I have two that would add to negative 10. So you want them to multiply to this number, but add to this number. So that would be negative 6 and negative 4. So that is the factoring. Now to solve, you can take each factor. Sometimes there's two, sometimes there's more. Set each one equal to 0, and then just solve them with algebra. So here I would add 6. Here I would add 4. So here are my two solutions, which is the same as roots, which is the same as x-intercepts on a graph. Okay, for number 2, I don't have the 0, so I'm going to start by getting everything on one side, which means subtracting that 9x. Now I'm always going to try to take out a greatest common factor first if I could. I should have mentioned for number 1 that I did look to see if I could do that, but I couldn't. So I can take out a 3 from both of these, and I can also take out an x. So that is the GCF, greatest common factor. If I take that out, which means divide, I would have x minus 3. Now I have factored, so I can take each factor and set them equal to 0 and solve. So here I would divide by 3, but that would still give me 0. Here I would add 3. So here are my two solutions, roots, x-intercepts. For number 3, not ready. So I'm going to move that 3 over and make sure it's in the right order, meaning x squared, then the x, then the constant. Now I'm ready to factor, but I have a number in front and I can't take it out. There is no GCF to take out. So there is a different way to do this, which is called the AC method. And I have a whole video on this if you've never done this or don't remember it. So maybe look that up later. But the AC method means you first multiply the A and the C. So in this case, that gets me negative 18. And then you find the two numbers that multiply to negative 18 and add up to negative 7, just like we did before, but the next step's going to be different. So what two numbers multiply to negative 18 that add to negative 7? You can keep listing and listing and listing. One number will need to be positive and one needs to be negative this time. So I can already think the negative 9 and 2 would do it. So the difference between what we did up here and here is we are not ready to just go to these two parentheses and be done factoring. With the AC method, once you find these two numbers, you rewrite the problem. So the 6x squared stays there, the minus 3 stays there, but instead of this negative 7x, I'm going to use these two numbers. So I'm going to write negative 9x plus 2x instead of the negative 7x. Now you're ready to do grouping. So grouping means I take out the GCF from these two, which would be 3x. That would leave me with 2x minus 3. And the GCF here, there is nothing, so you just put plus 1. Unless you wanted to change the signs, then you would put minus 1. And then if your parentheses match, you're good, because then that means you can go one more step to get to the final factored form. Since they both have the 2x minus 3, I can pull out the 2x minus 3 from both. So you pull it out from both, writing it once. And then what was in front of each one is your second parenthesis. So there's a bunch of steps, so that's why you might want to watch that video if you haven't done this in a while. But now that I have factored, same thing I did before, set each factor equal to 0 and solve. Here I would add 3 and divide by 2. So I get a fraction. Here I subtract 1 and divide by 3. So 2 fractions for my solutions this time. And number 4, there's other ways you could do this, but since I said to factor, if I was told to factor this, I would notice that this is a square because 2x times 2x could get you there. And this is a square because of 5 times 5. So that means this is a difference of squares, which can always be factored by splitting up the two terms and making 1 minus and 1 plus in the middle. So again, difference of squares. I have a whole video on that if you need it. Now I can set each one equal to 0 and solve. Subtract 5, divide by 2, I get a fraction. Add 5, divide by 2, I also get a fraction. So those are my 2 solutions, roots, x-intercepts. Okay, if you need more practice on factoring, like I said, I have those videos, so I would look at those. All right, graphing. First of all, this is a quadratic, so you need to know that your basic quadratic looks like this. Starts at 0, 0, over 1, up 1, over 2, up 4, because think squaring. And it looks like this. It's a parabola. So what has changed here? This, anything that happens inside affects it the opposite of what you would think. So this minus 1 actually moves us to the right 1. And then out here, this plus 3 moves it up 3. Again, I have a whole video about graphing quadratics. This negative's going to flip it. So it's going to go down instead of up. And the 2 is going to be a vertical stretch, which basically is going to make it skinnier. So let's graph. So the vertex of my new parabola is at 1, 3, because of going right 1 and up 3. And now I need to draw it going down and going down twice as fast as the normal parabola. So instead of over 1, down 1, which would just be the opposite of what I did here, I'm going to go over 1, down 2. Over 1, down 2. If I wanted to go over 2, instead of 4, I'd go over 2, down 8. I'm just going to kind of estimate this one because we get the idea. So that is a good enough graph for me. And now the domain and range. The domain is the x's. So I'm listing what numbers this graph used on the x values. So from left to right. And if you go from the left, there is no smallest x value because that arrow means it's going to keep going left and left and left forever. And then if I look to the right, same thing. So if there's an arrow to the left and an arrow to the right, I'm using all real numbers. And another way to write that is negative infinity to infinity. This is considered interval notation, and you always use parentheses with an infinity. Otherwise, you would use a bracket unless it was an open circle. So if you actually hit a number, you're going to use a bracket, but infinity is not really a number. So that's why we always use parentheses with infinity. And then the range is your y value. So we're thinking up and down. So if I'm coming from the bottom, again, I hit an arrow, which means it's going to go down into the negatives forever and ever and ever. So there is no smallest value again. So I'm coming from the negative infinities. And if I hit an arrow at the top, I'm going to infinity, but I don't. This graph clearly does not go any higher than this. And this is where the y value is 3. And it's not an open circle, so I do hit that value. So I need to use a bracket this time. Okay, same idea for b, except we're talking about a square root function. So remember, a normal square root function or the parent graph starts at 0, 0, over 1, up 1, over 4, up 2, because we're square rooting. So it looks like that. So what has happened to our graph? We went 1 to the right again and up 4. So 1 to the right, up 4. I should have drawn this lower, but you get the idea. So basically it's going to start there and go to the right. So what would be my domain? Well, I don't hit an arrow this time. So my first X value that gets used this time is 1, and it's not an open circle. So bracket 1, but then my largest Y value or X value, sorry, because we're doing domain, smallest to largest is an arrow. So that means it goes to infinity. And then my range, smallest Y value, I don't hit an arrow, I hit this exact point. So 4, but then at the top, I do hit an arrow. So infinity. So if you had any problems with any of that, or you couldn't do it at all, I have videos about all the different types of factoring. I have videos about graphing quadratics, about graphing other functions like square root, and I have a video about functions and finding their domain and range. So you can look at all of those if you need more information about any of these topics. But I hope for now that that helped. See you next time.